I am Dr. Ramya Swetha, Assistant Professor, Department of Civil Engineering from Institute of Aeronautical Engineering. Today our topic is jet grouting. As a part of ground improvement techniques, we have understand and different number of methods or techniques for improving the soil properties based on the requirement of the construction work, whatever the construction project it is. In that, this grouting, jet grouting is one of the technique which we are used for the soil modification. It means soil property modifications. In this, jet grouting is an advanced ground improvement technique that involves the high pressure injection of grout into the soil to create soil-crete columns, which are mixtures of soil and grout, form a solid mass. So, we know about the grouting. Coming to the jet grouting, it is the advanced technique which we are used for the improvement of the soil. So, in this, we are injecting this high pressure of grout into the soil to create soil-crete columns, which are mixtures of soil as well as the grout that form a solid mass. What is the purpose of this jet grouting means? It improves the soil parameters, improve the soil properties such as strength, stiffness, impermeability, making it suitability for a variety of geotechnical applications. So, this is the purpose of the jet grouting. Now, in this lecture, we are going to understand create impermeable barriers to prevent groundwater flow by using the jet grouting, and also increases the load bearing capacity of the soils, reduce settlement and improve stability of structures, and also construct foundation elements in difficult soil conditions based on the jet grouting, stabilize soils for tunneling, excavation support, and remediation of contaminated sites. These are all variety of objectives we are going to understand in this particular lecture. End of this lecture, we have some sort of idea regarding where this jet grouting is suitable, how we are implementing this application. Once we are applying this application, what are the changes are occurred in the soil property? These are the objectives which we are going to understand in our using this jet grouting technique. Types of jet grouting. So, different types of jet groutings are available for choice based on the requirement of the soil properties as well as the which type of project we are going to construct. Based on these parameters, we are going to choose the type of the jet grouting. In this, single fluid system, double fluid system, triple fluid systems are there in jet grouting. Single fluid system, double fluid system, and triple fluid systems are the different types for jet grouting. In this single fluid system is the most straightforward form of jet grouting. So, in this single fluid system, it is going to involve the use of high velocity jet of grout, which is typically cement slurry. So, based on the cement slurry, it involves the use of high velocity jet of grout. Jet grouting has its high pressures. So, this high pressure jet is directed into the soil through specialized nozzles located on a rotating rod. The force of the jet erodes the soil and simultaneously mixes the grout with the eroded soil particles, creating a homogeneous soil grout mixture known as soilcrete. The process of relies solely on the hydraulic energy of the grout to disaggregate to the soil and facilitate the mixing process. So in this we are going to jet is inducted through the soil based on the specialized nozzles located on the rotating rod, and we are going to force jet erodes to the soil simultaneously mixes the grout with eroded soil particles, creating a homogeneous soil grout mixture. It is known as soilcrete. The process is relies solely on the hydraulic energy of the grout to disaggregate it to the soil and facilitate the mixing process. It is going to apply the single fluid system is particularly suitable for soils with low cohesion such as loose sands, silts and softy clays, where the hydraulic energy of the grout can effectively displace and mix with the soil. This is the one of the condition we are going to use this jet grouting single fluid system type. It is also used in scenario where soil replacement is necessary. Whenever the soil replacement is necessary, as the high pressure grout can easily erode and replace the existing soil structure. So, whenever we require the replacement of the existing soil structure, we are using high pressures for the jet grouting. So, that high pressure is enough to erode the existing soil and also replace the soil using this single fluid system of the jet grouting. Such type of scenarios we are going to use this. We are apply the single fluid system jet grouting. Typically, application include underpiping existing foundations, creating impermeable barriers and stabilizing loose or liquefiable soils. So in these cases, we are using jet grouting, single fluid system of jet grouting. Next one is double fluid system. In double fluid system, enhances the soil erosion and mixing process by combining high velocity jet of grout with an air jet. So in this, the combination of high velocity jet of grout with an air jet, the mixing process is combining based on these two parameters and it enhances the soil erosion. In this system, the grout is injected through a central nozzle while compressed air is simultaneously injected through an outer nozzle surrounding the grout nozzle. So, in this system, we are going to understand well while compressed air is injected through an outer nozzle surrounding to the grout nozzle. The addition of the air jet helps. We are combining high velocity with an air jet. The addition of air jet helps to increase the erosion capability. It increases the erosion capability of the grout jet by creating a cavitation effect which breaks down soil particles more efficiently. The air jet also helps to disperse the grout more uniformly within the soil, resulting in better mixing and more consistent soilcrete properties. This is the overall scenario of the double fluid system. So, in this, it enhances the soil erosion and combining the high velocity as well as the air jet for additional erosion of the grout, erosion for the grout by this jet creating and cavitation effect. And finally, it is grout more uniformly within the soil, resulting in the better mixing and also consistent property. Where we are going to apply this double fluid system. The double fluid system is effective in wider range of soils compared to the single fluid system. It can handle soils with varying degrees of cohesion, including sandy and silty soils, which are more challenging to treat with single fluid system. This system is often employed in projects requiring higher levels of soil improvement and where more uniform mixing is critical. Applications include the creation of ground improvement zones beneath existing structure, stabilization of soils for excavation support, and formation of cut-off walls to control of groundwater flow. We are going to apply this double system jet grouting in the following applications. Triple fluid system. In triple fluid system, it is more advanced form of jet grouting, utilizing three separate jets: water or air, water jet, grout and air. So in this the triple are water, grout and air. These three different jets we are using in this triple fluid system. The process involves a central jet of water to initially erode the soil. The jet of water initially erode the soil, followed by high velocity jet of grout to mix with the eroded soil particles and an additional air jet to further enhance the erosion and mixing process. The water jet, typically operating at extremely high pressure, creates a highly erosive action that can be break down even the dense set or hard set soils. The triple fluid system is for hardest type of soil also. It is going to erode because of its high velocity and also the addition of the air grout and also the water jet. Air jet plus water jet plus the grout. Combination of these three jets in triple fluid system, it is able to erode and in the mixing are also enhance the more erosion property. So based on all this, it has capable for erode and mixing and doing the jet grouting in hard set soils also. The grout jet then mixes with the loosened soils where the air jet erodes through an dispersion and mixing, resulting in a highly simultaneous soil-crete column is created. So, this is the triple fluid system. The triple fluid system is used in the most challenging soil conditions such as dense sands, gravels and hard clays where maximum erosion and mixing efficiency are required. So here we are going to apply whenever the maximum erosion and the mixing efficiency are required, we are going to choose this triple fluid system. It is most challenging conditions we are going to face in this triple fluid system of the jet grouting. It is particularly useful in urban environments where precise control over ground improvement is necessary to avoid damage to adjacent structures. Typical applications include construction of deep foundation elements, stabilization of soils and embankments, and remediation of contaminated sites by creating impermeable barriers. This system is also employed in infrastructure projects requiring deep soil stabilization and improvement, such as bridges, abutments, tunnel shafts, and deep excavation. These are the applications for triple fluid system jet grouting. Jet grouting process. Drilling, grouting, column formation is the major steps involved in the jet grouting process. Drilling, grouting, and column formation. In drilling reach, borehole diameter are the parameters for understanding the jet grouting process. In drilling, used to create boreholes to the required depth. Typically ranges from 100 mm to 200 mm. Jet grouting rod equipped with nozzles for injecting grout at high pressures. Rotation and lifting. The rod is rotated and lifted at a controlled rate to ensure uniform treatment. In injection parameters, grout pressure, flow rate, injection time are the parameters for better injection for getting the better grouting results. So in grout pressure can exceed 400 bar. Flow rate typically ranges from 50 to 150 liters per minute. Injection time depends upon the required column diameter and soil conditions. How much diameter and what are the soil conditions are there. These are the dependent parameters for the injection time. So in these injection parameters and rotating and lifting, jet grouting rod, based on all these, we are that resulting the best grouting. Column formation depends upon the diameter, depth and shape. These are the major parameter which are depending on the column formation. Diameter typically ranges from 0.5 to 3 meters. Depth can reach up to 50 meters or more. Shape of the columns, generally cylindrical columns, panels are complex geometrics only. So which type of shape and how much depth it is going to reach, what is the diameter of the column formation are the parameters. So these are the processes we are going to understand in our jet grouting process. Jet grouting design considerations. Soil conditions, grout properties, injection parameters, column geometry. Soil conditions. Which type of soil it is and how much the water table is there, how the groundwater is behaves and what are the properties are there, the presence and pressure, all the parameters which are relevant to the groundwater and also the soil type. Soil type, grain size, cohesion, permeability affect the grout penetration and column formation. So, these are the important parameters for jet grouting, creating for penetration and also the column formation. And groundwater, presence and pressure of groundwater influencing the grouting process. These are the soil conditions we are considered for design of jet grouting process. Grout properties, type of grout, mixed design. Which type of grout? Commonly cement based but can include additives to enhance the properties. Generally we are choose cement only, but it depends upon the condition of the soil location. It requires any additions, we are going to use those additives to enhance the properties or to get the desired properties. To get the desired properties. Mixed design, water cement ratio, additives, and viscosity tailored to specific soil and project risk requirement. It depends upon the specific soil and also the project requirements. Injection parameters, pressure and flow rate, rotation and lifting speed. In pressure and flow rate, critical to achieving desired soil mixing and column quality, and rotation and lifting speed must be controlled to ensure uniform grout distribution. In injection parameters, pressure and flow rate, rotation and lifting speed. How we are going to that lifting speed is dependency in the injection parameter. We are going to consider these as a design consideration. So, in this pressure flow rate, critical to achieve desired soil mixing and column quality. Rotation and lifting speed must be controlled to ensure uniform grout distribution. Column geometry, spacing and overlap arrangement. So, the column geometry is based on the spacing and overlap and also the arrangement. Spacing and overlap ensuring continuity and effectiveness of the treated zones. Move on to the arrangements. Patterns such as single columns, overlapping columns or panels based on the project needs. So, these are the design considerations for the jet grouting. Equipment and methods. In this, jet grouting rig is capable, must handle high pressures and precise control of rod rotation and lifting. Types: hydraulic or electrical rigs with varying capabilities based on the project size. Grout mixing plant, batch mixers, continuous mixer. So batch mixers are suitable for small projects with precise control over mix proportion. Coming to the continuous mixers, ideal for large projects, providing a constant supply of grout. Monitoring system, pressure gauges and flow meters, essential for a real-time monitoring and control of injection parameters. Data logging, automated systems to record injection data for quality control. Quality control and testing. Pre-grouting test, during grouting, post-grouting tests are available for quality control. For getting quality pre-grouting, during e-grouting, post-grouting for understanding the quality control. In pre-grouting test, soil investigation, borehole logs, soil samples and laboratory tests to determine the soil properties, pilot test, initial test to columns to verify grout mix and injection parameter. During grouting, monitoring injection parameter, visual inspection. In monitoring injection parameters, ensuring pressures, flow rates and lifting speeds are within the design limits. In visual inspection, observing grout returns and column formation at the surface. Post-grouting tests, core sampling, strength testing, load testing. Extracting cores from treated columns to assess grout distribution and column integrity. Strength testing, laboratory test on core samples to determine the compressive strength. Load testing, assessing the load bearing capacity of the treated ground. Some of the case studies and their application. Foundation stabilization considered as a case study. Example, jet grouting to improve bearing capacity and reduce settlement for the building foundation. Using this jet grouting, what is the outcome we will get is that enhanced stability and load bearing performance. In tunnel support, pre-excavation jet grouting to stabilize soils and control groundwater during tunneling. We are using suitable jet grouting technique, whether it is single fluid system, double fluid system, triple fluid system, based on understanding the soil properties. Final outcome is safer and more efficient tunnel construction we are getting using this jet grouting technique. Cut-off walls. Example, creating impermeable barriers and around contaminated sites to prevent groundwater contamination. Cut-off walls, creating impermeable barriers around contaminated sites to prevent groundwater contamination. Using this jet grouting technique, suitable jet grouting technique, we will get the effective containment of pollutants and protection of groundwater resources is the outcome. Soil stabilization parameter example, jet grouting to reinforce slopes and prevent landslides. We are using this technology, finally improved slope stability and reduced risk of landslides. Advantages, versatility, precision, strength and durability, minimal disturbance. Able to use wide range of soils and ground conditions. Controlled injection parameter ensures uniform treatment in precision. Provides significant improvement in soil properties. It can be performed within minimal disturbance to the existing structures and operations. In this also, we have some limitation, that is cost. Minimum limitations are there, but even though that is important parameter for identifying, that is the cost. High initial cost due to specialized equipment and materials. We are using this specialized equipment and also the material also. Complexity requires skilled operators and precise control of injection parameter is required for better grouting. In jet grouting, it's very, very important. Environmental concerns, potential of for groundwater contamination if not properly managed. It is going to affect the groundwater if properly not managed the overall jet grouting process. These are the limitations we have to understand in our jet grouting. Further developments, innovation in grout materials, eco-friendly and sustainable ground formulation, self-healing grouts that can repair cracks over time, advanced injection technologies, automated and robotic systems for more precise and efficient grouting. It gives the precise and efficient without less the human errors. Real-time monitoring, adaptive control systems using AI and machine learning, enhanced monitoring and testing, improved geophysical methods for pre and post grouting assessment, integration of remote sensing techniques for real-time data collection. Overall summary, jet grouting is highly effective ground improvement technique which diverse application in construction and geotechnical engineering. Some of the web references for understanding the ground improvement techniques. Thank you. We will see in our next class.
Like, share and subscribe. Hit the bell icon for more updates.